There are 400 billion stars in our galaxy, billions of planets, and our galaxy is just one of trillions in the universe. So where is everyone? Why haven't we found a single shred of evidence for alien life? This is the Fermi Paradox, and the answer might terrify you. Let's talk about the numbers. Our Milky Way galaxy alone contains between 200 to 400 billion stars. Recent estimates suggest there could be at least 100 billion planets in our galaxy. Scientists believe at least 20% of Sun-like stars have Earth-sized planets in their habitable zones. That's 20 billion potentially habitable worlds, just in our galaxy alone. Now zoom out. There are an estimated 2 trillion galaxies in the observable universe. We're talking about more planets than grains of sand on every beach on Earth. The universe is 13.8 billion years old. Earth is only 4.5 billion years old. That means there are star systems billions of years older than ours. If life emerged on just one of those ancient worlds, they could be billions of years more advanced than us. Imagine what a civilization could achieve with a billion-year head start. So here's the paradox. With all these planets, all this time, and all these opportunities for life, where are the aliens? Why haven't we detected any radio signals or found any evidence of advanced civilizations? This question was first posed by physicist Enrico Fermi in 1950. He simply asked, "Where is everybody?" And the question has haunted scientists ever since. In 1961, astronomer Frank Drake tried to answer this with an equation. The Drake equation estimates the number of active extraterrestrial civilizations in our galaxy. When you plug in even conservative numbers, the equation suggests there should be thousands, if not millions, of intelligent civilizations in our galaxy alone. So why haven't we found them? One terrifying explanation is called the Great Filter. This theory suggests there's some barrier that prevents life from reaching an advanced stage. The question is, where is this filter? Is it behind us or ahead of us? If the filter is behind us, it means the emergence of life itself is incredibly rare. Maybe the jump from non-living chemistry to living cells is nearly impossible. Or maybe intelligence itself is the rare thing that almost never happens. But if the Great Filter is ahead of us, that's much more terrifying. It would mean something destroys civilizations before they can spread across the stars. Nuclear war, climate catastrophe, artificial intelligence gone wrong, asteroid impacts, or something we haven't even imagined yet. The fact that we haven't found any evidence of alien civilizations could mean they all destroy themselves before reaching our level. Here's a less terrifying possibility. Maybe aliens exist, but they're deliberately avoiding us. This is called the zoo hypothesis. Advanced alien civilizations might be watching us from afar, just like we observe animals in nature reserves without interfering. Perhaps there's a galactic code of conduct, and Earth is protected as a kind of cosmic wildlife preserve until we're ready for contact. Or maybe the reason we haven't heard from aliens is much darker. The dark forest theory suggests the universe is like a dark forest full of armed hunters. Every civilization is trying to stay hidden. Why? Because any civilization that reveals its location risks being destroyed by others. In this scenario, the universe is full of civilizations, but they're all hiding. They're all listening, but no one is transmitting. Because announcing your presence to the cosmos might be suicide. The dark forest theory explains why SETI has found nothing despite decades of searching. Another possibility is that we're simply too early. The first generation of stars didn't have the heavy elements needed for planets and life. It's possible that Earth is one of the first planets to develop intelligent life. We might be the early birds, the first to arrive at the cosmic party. What if aliens are already here, but we just can't detect them? A civilization a million years more advanced might use technology so sophisticated it's invisible to us. They could be communicating through quantum entanglement or existing in dimensions we can't perceive. It would be like an ant trying to understand the internet. Some scientists believe Earth is genuinely special. This is the rare Earth hypothesis. While simple life might be common, complex life requires incredibly specific conditions. We need a star like our Sun, a planet the right size at the right distance, a large moon to stabilize our orbit, a magnetic field, and Jupiter to shield us from asteroids. Maybe all these factors together are so rare that intelligent life is virtually unique to Earth. Perhaps alien civilizations did exist, but they're extinct now. A civilization could have risen and fallen millions of years ago, and we'd never know. Their radio signals would have passed us by long before humans existed. We might be living in a universe full of dead civilizations, cosmic ghost towns. Maybe we're looking for the wrong things. We've been searching for radio signals, but what if advanced civilizations don't use radio anymore? We used radio for less than a century before moving to other technologies. An advanced civilization might communicate through methods we haven't discovered yet. Here's a wild one. What if we're living in a simulation? If our reality is a computer simulation, the absence of aliens might simply be a design choice. Perhaps aliens are waiting for us to reach a certain milestone before making contact. Maybe there's a galactic community you only join once you achieve certain technological breakthroughs. Despite the paradox, the search for extraterrestrial life continues. The James Webb Space Telescope is analyzing exoplanet atmospheres looking for biosignatures. The Breakthrough Listen project is scanning millions of stars. NASA's Perseverance rover is searching for ancient life on Mars. We've discovered thousands of exoplanets in habitable zones. We've found organic molecules in space. We've discovered subsurface oceans on moons like Europa and Enceladus. The Fermi Paradox forces us to confront profound questions. Are we alone? Are we special? Are we doomed? If we're truly alone, it makes Earth and humanity infinitely precious. We might be the universe's only chance to understand itself. But if aliens exist and we just haven't found them yet, first contact could be the most important moment in human history. Whether we're alone or not, the Fermi Paradox reminds us of our responsibility. If the great filter is ahead of us, we need to be careful. We need to solve climate change, prevent nuclear war, develop AI responsibly, and become a multiplanetary species to ensure our survival. So why haven't we found aliens yet? The truth is, we don't know. Maybe we're looking in the wrong places. Maybe we're too early or they're hiding. But the search continues, and every day brings us closer to an answer. The universe is vast, ancient, and full of mysteries. And somewhere out there, among the stars, the answer to the Fermi Paradox is waiting to be discovered. So what do you think? Are we alone in the universe? Or are aliens out there hiding from us? Do you believe in the great filter, the dark forest, the zoo hypothesis? Drop your theory in the comments below. If you enjoyed this deep dive into the Fermi Paradox, smash that like button. It really helps the channel grow. And if you want to explore more cosmic mysteries like black holes, dark matter, and the origins of the universe, make sure to subscribe to Cosmic Mysteries. Hit that subscribe button and turn on the notification bell so you never miss a video. We post new mind-bending space content every single week. Thanks for watching Cosmic Mysteries, and remember, the truth is out there. We just have to keep looking. See you in the next video.